Hello learners, today we are going to talk about different types of diodes. A simple PN junction diode is what we have discussed in the previous lecture. Now, on the basis of the electrical and optical behavior of the diodes, we have 4 different kinds of diodes which we are going to talk about. A Zener diode, a photodiode, a light emitting diode and a solar cell. To begin with, let's talk about the Zener diode. This is the symbol of the Zener diode. A Zener diode typically works in reverse bias. Basically, a Zener diode is a PN junction diode with heavily doped P and N region. It has a very narrow depletion region and it is mainly used for voltage stabilization or regulation. Let me show you a Zener diode as such. This is the Zener diode which is used in reverse bias. A Zener diode acts like a voltage stabilizer or voltage regulator. Let's understand the diode characteristics when it works as a Zener diode. A typical Zener diode is always connected in the reverse bias. Now, in the reverse bias, the diode is operational beyond the breakdown voltage. Beyond this breakdown voltage, what is being observed is that there is a sharp increase in the value of the current without any change in the value of the voltage, and thus a Zener diode typically works in this particular region where there is no change in the voltage while there is a sharp change in the current, and that's why it works like a voltage stabilizer or a voltage regulator. So, the main function of the Zener diode is voltage stabilization or voltage regulator. Another type of diode is a photodiode. A photodiode is basically a PN junction diode which basically uses light emitting semiconductor with a very thin P region. This is the symbol of the photodiode. The photodiode receives light and then converts it into electrical current. It is basically used as receivers for remote. Let's look at the characteristics of the photodiode. A photodiode primarily works as a forward bias diode. Beyond a certain voltage value, there is a sharp increase in the current and thus the diode works like this. So, the prime region in which the photodiode works is the first quadrant of the graph, that is the forward bias. Let me show that on the graph. This is the region where the photodiode works. So, when the light falls on the photodiode, there is a sharp increase in the current and the diode is conducted in the forward bias. The basic use of photodiode is as receivers for various remote devices. Let's move on to the next kind of diode, which is a light emitting diode. As the name suggests, a light emitting diode gives out light when it is allowed to conduct, which means that it converts the electrical current into light energy and gives out the wavelength in the visible region. A light emitting diode is represented like this, where these indicate the light pulse moving out of the diode. A PN junction diode is basically made with materials having band energies near infrared region or the visible region. Common type of material used for diode are gallium arsenide phosphate or indium phosphate. Some of the common uses of this light emitting diode are multimeters, digital displays and watches. Now, what we are looking at is an LED. This is a light emitting diode. The light emitted diode primarily works in the reverse bias. A large value of voltage is given and the diode gives out current. So, when the visible light falls onto the semiconducting material which is photosensitive, it gives out light in the form of visible wavelength. In case of a light emitted diode, an electrical current is given so that visible light is given out. Basically, the visible light is close to the red region of the spectrum. As the current of the diode increases, the corresponding wavelength changes. The characteristic curve of the LED is shown over here. The diode operates in the reverse bias, and therefore, when we give current to the diode gives out wavelength of a particular light. As the current shows a change, the wavelength also shows a corresponding change. This is IV characteristic curve of a light emitting diode. Let's talk about the fourth kind of diode, which is a solar cell. A solar cell is a special kind of a photodiode. Basically, a solar cell absorbs solar energy and it gives rise to electric current. It's a great renewable source to give out current using solar energy. A solar cell is basically a PN junction diode with a very thin P or N region. In this case, the EMF is created due to these three distinct processes. In case of a solar cell, the EMF is created due to the generation of the electron-hole pair. These electron-hole pairs are generated due to the incident light onto the solar cell. As soon as these electron-hole pairs are generated, these electrons and holes are drifted towards the N-type and the P-type of the diode. Thus, a large number of electrons and holes are collected towards the N side and the P side of the diode, generating an EMF. When this diode is connected in a circuit, a large amount of current begins to flow. These solar cells find applications in satellite power systems, battery charging and calculators, to name few. There are immense applications of the solar cell. This is a solar panel, which is a collection of large number of solar cells. In this 2.5 by 2.5 chip, there are around 400 solar cells. A solar cell in an open circuit is shown in this graph. The graph in the fourth quadrant indicates the IV characteristics of a solar cell. In an open circuit, when light falls onto the solar cell, the electrons move from one side towards the P end and the holes move towards the P side. Both the N and the P side collect a large number of electrons and holes, thereby generating an EMF. So, in the short circuit condition, that means when the current is drawn from the circuit, a large amount of current across that EMF flows to the circuit. This represents the IV characteristic curve of the solar cell. So, in today's lecture, we talked about different kinds of diodes: the Zener diode, the photodiodes, the light emitting diodes and the solar cells. Thank you, learners.